Yeah, we want to welcome you back. This is Richard, and the channel is Physical Sciences Silver Bullet. Now, we have come to apply what we have been studying. This is one of the questions which I've extracted from my book. I have two books which I wrote. One is called Guidelines to Physical Sciences, and the other one is called Silver Bullet, of which the name of this channel was derived. So now this is one of the question. I've just picked it from the Guideline to Physical Science, and we are applying what we've been studying all along. Now I want you to tell you that if you find any problem with the answering of these questions, we would urge you to go back to the videos and go through them. We have the belief that they can guide you to answering all these questions which are going to come. And another thing is that you should not forget to subscribe. Your subscription means a lot to us, and also to remind you to interact with us, and also if it's your will, to like our videos. Okay, now this is one of the first questions we are going to look at. This is a setup which was put across to electrolyze copper 2 chloride solution using graphite. So these two electrodes are graphite, and the question comes. It says, give a reason for the choice of graphite as an electrode. Graphite is one of the most common electrode used in electrolysis. But what property does it have which makes it a good, suitable choice? The first one is it is a good conductor of electricity. Yes, it is a non-metal. Those of you who did grade 10 and grade 11 chemistry very well, it's a non-metal, yes, but its atoms are laid in layers with the free electrons between those layers, which gives it the ability to conduct electricity. The second reason for choice of graphite is that it is inert. What does this mean? Graphite does not react readily with electrolyte or products of electrolysis. So that's one of the questions. Another, there comes the second question. Write equation for dissociation of copper to chloride. Now, we have to remember that copper to chloride is written like this. That's the formula. Because copper has a valence of 2 and the chloride has a valence of 1. So when it dissociates, it gives you copper 2 ions plus chloride ions. So because of these two, we put a 2 here to balance the equation. So that's what we have in the solution. Now, this question seeks for the half reaction at electrode A and electrode B. Now, how do we answer this question? You have to go to the battery. The battery gives us the polarity. The small stick here is the negative, and the long one is the positive. Now, you need to be reminded that what we call the electrolyte actually are ions. The copper 2 ions and the chloride ions. After that, you have to know the mechanism of conduction. The positives move to the negative, and the negatives move to the positive. In other words, the cations move to the cathode, and anions move to the anode. So let us look at what A is. A is positive, so it is the anode. And what moves at the anode is our chloride ions. So what happens there? The chloride ions, they undergo, because it's anode, they undergo oxidation to give you chlorine gas. Before you proceed here, you see that these two are not balanced. So you put a 2 here to balance, but the 2 also helps you to give you the number of electrons involved. And how many are they? Now it's -1 times 2, which makes it 2 electrons that side. Now, when you come to B, what happens to at B? At B, the positive ions or the cations are moving there because B is cathode. We know that the reaction which is going to take place at the cathode is a reduction. So the copper ions come, they take up electrons, and they become reduced to copper solid. That is how we answer that question. Now, question 1.46 for the net reaction. The net reaction is made up of the summation of these two half cells. The one for oxidation and the other one for reduction. So when you look at these two half cells, what do we do? I'm sorry, I'm going to encroach on them. You cancel the electrons out and you write what remains after that, which is going to be 2 chloride ions plus copper ions, giving you chlorine gas plus copper solid. So this is our net reaction. Now, this question comes again now. State the observable changes at A. What do we see at A? To answer this question, you need to have the equation. Remember, the equation at A, which is the anode, was chloride ions becoming what? Chlorine. And after balancing, the 2 electrons come there. Now, what you see here, this side, is what you observe. Now, what do we observe? We observe this. A greenish yellow gas forms at A. So we'll be seeing bubbles of greenish yellow gas forming at A. So let us come to B. What do we observe at B? It also comes from the equation. This is what we see. the equation comes and says, oh, we are having two copper ions being reduced to copper solid. That is the equation taking place at B. Now you have to know that what you observe at B is this one, the copper solid. Now, how do you write that? What we say, actually what happens is that copper solid is going to come and become deposited on this electrode. So, by chance, if you know the color of copper, because copper solid, the color is brown, so you can say brown solid is deposited at B. Okay, what does that lead to? It leads to another observation, which is increase in size. If you don't know what size, you can say mass of B. That one is also observed. That one can be answered also like that. Then 1.6 comes. It says, by use of arrows, show direction of flow of electrons. Now, the best way you have to remember here is that electrons are negatively charged. So if they are negatively charged, it means that they flow towards the positive. So remember, this long one is positive and this one is negative. So they flow towards positive like this because they are negatively charged, and they move out of negative. Now, we normally tell our learners something else. Suppose the polarities are not shown. We tell them that electrons move from anode, which is A, it's very easy to remember, to cathode, which is C. Why this one is so easy to remember? Because A comes before C. So the movement of electrons is from A, which is our anode here, to C, which is our cathode. Now we come to question 1.7. It says, state the observable changes in the color of electrolyte. Now, to answer this question, truly speaking, you need to find out the net reaction. So let us construct the net reaction here. What did we say? We said that our chloride ions were oxidized to chlorine as per this equation, and copper ions were reduced as per this equation. Now, the net which comes out of this will be 2 chloride ions plus Cu2 plus, giving you chlorine plus copper solid. Now, not every change here can indicate color change, but we cannot oversee this one. Let us look at here. These ions here, they are blue in color. And what do we see? These ions here are turning into copper solid which is deposited, not even remaining in the solution but deposited. So the gradual removal of copper ions affects the color. Remember, the blue color was brought about by the copper ions, and now these copper ions are shifting or are gradually being reduced to copper solid. So what do we say here? We say the intensity of the blue color copper to solution decreases. That's why if the reaction is allowed to proceed for a long time, it will disappear. That's how we answer that one. Then comes this question 1.8. It says use electrode potentials to show that that the cell above is non-spontaneous. So how do we answer this question? We'll go back to our equation. The cell potential or standard cell potential is given by E naught, which is equal to E naught cathode minus E naught anode. That is it. So what do? We have to substitute. You have to remember that our cathode is this part, and it's copper which is coming there. So when you get the value of copper, you're going to get it as 0.34. That's the standard reduction potential of copper. Now for the anode, it is the chlorine which we check for, and chlorine is positive 1.42, so it's 1.42. So what do we get out of here? When you subtract, you get negative 1.08 volts. Now I want you to take note of this negative. Is this negative which indicates that the cell we are dealing with is non-spontaneous. Actually, I would like to tell you that all electrolytic cells are non-spontaneous. It's the reason why you see a battery here. It means that without this battery, they cannot proceed. What is a non-spontaneous cell? It is the type of cell which requires an external energy to proceed. So in other words, the energy which drives this cell, it comes from the external source, and this external source is the battery. And that's that. Now, the last one of this series of questions is this one. Why DC energy source is used instead of AC energy source? You have to know that the battery and the other kinds of energy sources of this manner, what is the manner? Which maintains one side positive, permanently positive, and one side permanently negative, are called DC source. And why do we use them here, not AC? The answer is very simple, that our intention is to make sure that these ions, they move in one direction. So by maintaining this part negative, we continuously manage the movement of all the positive charges to the negative terminal and all the negative ions to the positive terminal. So that's the reason why we use this. If you use AC, what will happen? The charges will sag, will move in one direction, and when the current changes, it will come back into the opposite direction. So you won't have any kind of motion. So the reason here is that to ensure that charges move in one direction. Thanks. That's one of the questions, and more will be coming. Don't forget to subscribe.